Hey class, so it's been requested that I make a video for number 58 on the homework.
V equals IR.
That's my wife helping you guys out since we're going to use V equals IR on this one. Her favorite equation from the good old days of electrical engineering.
/ the only one I remember.
So, yeah, good stuff, V equals IR. So we're going to use that among other things. So what we're asked here is to figure out what the EMF required or to be supplied by this battery is as we observe that the current is a function of time. So the current being a function of time tells us that the rate of change of the current varies, that the current is changing with respect to time, which means that there's going to be a back EMF here labeled EL in our inductor. So we need to try to figure out what the EMF is of this battery at this time t, in this case, equals 4 seconds. So the question is, how are we going to go about solving this one? It's pretty tricky. I didn't give you a lot of clues on this one, so I'm guessing some of you have gotten stuck a little bit. But the key here is actually to go back to the loop rule. Boom, loop rule is our friend. It still applies. So let's do a loop rule here, knowing that the sum of the voltages around this loop is going to be equal to 0. So if we apply the loop rule, we can see that we're going to have the EMF from the battery minus IR, V equals IR, right? My wife's favorite equation for us there. And then minus this back EMF from our inductor, and that's going to be equal to 0. So if you recall from class, the magnitude of the EMF from the inductor is going to be equal to L times di dt, the rate at which the current is changing with respect to time. So if we plug that in and move these two here over to the other side of our equation, the EMF from the battery is just going to be equal to I times R plus this E from the inductor, the back EMF. So that's L di dt. So if we plug in our values, we can see that the EMF required is going to be equal to I, which is given by this equation here. So we got 1.5 plus 3t, and our units are going to be amps for that, multiplied by our resistance of 4 ohms, and then plus L, which is 6 Henry, multiplied by the derivative with respect to time of I, which comes out to just be equal to 3, and our units for all of that should come out to be volts, since I forgot to write the units in there. So again, quite simply, right, here we have I, here we have R, here we have the inductance L, and here we have di dt. So that should enable you to go ahead and solve. Let me know if you guys have any questions. Have a box-worthy evening. Here you go. Just for you guys. Yay. All right, anyway, have a box-worthy evening.